this lesson, we're going to talk about some basic matrix operations. So a capital letter is used to refer to the entire matrix, and this matrix is referred to as matrix A or just A. So this is matrix A, and the dimensions are always row by column. So this is 3 rows, 2 columns, so this is a 3 by 2. A specific element can be referred to using subscripts to indicate the row and column where the element is located. So, for instance, we have like Aij indicates that you have an element in row I and column J. So the first letter is always the row, the second is the column. So in matrix A32 refers to the element that's in row 3, column 2, which is 8. So row 3, this would be row 1, 2, 3, and column 2, this would be column 1, column 2. So 3, 2 would be the number 8. Equal matrices have the same dimensions and corresponding elements are equal. So if we take a look here, what are the values of the variables in the matrix equation? Well, I know that this first position, this top left, row 1, column 1, they're both 12, right? They have to be equal. So I have 0 and a y. Well, y has to be equal to 0. 2x has to equal 14. So obviously x is going to be 7, but if you needed an equation for that, 2x has to equal 14. If you solve for x, x is 7. And then 10 has to equal 10. So y would be 0 and x would be 7. All right, number 2, Cool Threads, a clothing store, uses a matrix C to represent the prices of women's clothes. The columns represent the brands, vintage, casual, and distressed. So I have vintage, casual, and distressed. And the rows represent jeans and jackets. So we have jeans and we have jackets. If the sales tax rate is 5%, how can you use a matrix operation to find the amount of sales tax on each item? Well, these would be vintage jeans, casual jeans, distressed jeans. This would be vintage jackets, casual jackets, distressed jackets. So I have 6 items here, and their tax rate is 5%. They want that on each item. So we use what we call a scalar. Now 5% as a decimal is 0.05. So I would be taking 0.05 times this matrix. So essentially what is going to happen is I'm just going to distribute this. So when we have a scalar out front, you can distribute it like you would normally. So I'm going to take the 0.5 times the 320 and the 0.05 times the 210 and the 0.05 times the 160 and the 0.05 times all 3 of these, and that would get me my sales tax on each item. So when we do that, the dimensions are not going to change because we're literally just taking and multiplying by a scalar. So we're going to get 16, 10.5, which would be 1050. So I'm going to put 2 decimal places there since it's money. 8, 12, 550, and 325, and this represents the sales tax on each item, which is fairly cheap, 5%. All right, so Cool Threads, same thing, is using a matrix to keep track of monthly sales. In matrices A and B, row 1 represents the sale of jeans, and row 2 represents the sale of jackets, with the columns representing vintage, casual, distressed brands, respectively, during 2 consecutive months. So matrix A here is for March, matrix B is for April. Now, you can't look at these right here because this is a 3 by 3, which doesn't make any sense to this matrix right here. So you have to go off of what they told you in the problem. So you know that matrix A is a 2 by 3 and matrix B is also a 2 by 3. It says, what is the sales total for 2 months? Well, I know that each one represents the sales total for the month of March and for the month of April, so I would just add those 2 together. So for part A, we will be adding together matrix A, and matrix B. Now, fun fact of the day, you have to have the same dimensions in order to add matrices together. If you don't have the same dimensions, then you don't have the same spots. So when we're adding, we are literally going to take the same locations and add them together because they represent the same items. So I know that I have vintage, and then my top row is jeans. So vintage jeans, we add 14 and 18. All right, so 14 and 18, we're going to add those together. That makes 32. Then we add together 11 and 17. That gives us 28. 28 plus 25, that gives me 53. And you want to make sure that you leave some space in between. Otherwise, if your numbers run together, you might accidentally think you have a different number. All right, and then we have 10 and 16, which gives us 26. 15 and 9, which gives us 24. 35 and 45, which gives us 80. And there would be my sales total for the 2 months. Okay, part B. What is the difference in number of items sold each month? So we have matrix A. Difference means that we are subtracting. So we'll subtract April, which is matrix B. So we have 14 minus 18 is negative 4. So that means that we sold 4 more of that item in April than we did March. 11 minus 17, that's negative 6. So 6 more of those were sold in April than in March. 28 minus 25 is 3. So we sold 3 less in April. 10 minus 16 is negative 6. 15 minus 9 is 6. And 35 minus 45 is negative 10. All right, so consider matrices M and N. So we have a 2 by 2 and a 2 by 2. They're wanting us to add and subtract. So first we are adding M and N, and then we're going to add N and M. And if you know about addition, you know it doesn't matter which way we add, we should get the same thing. So if I add together, let's do M plus N first. We have negative 3 plus 6, which is 3. 5 plus 5, which is 10. 2 plus negative 8 is negative 6. And 0 plus 0.2 is 0.2. Now, if we add the other direction and do N plus M, and I know I'm not writing those as capital letters, but they should be capital letters. So if I'm adding together N and M, it does not matter. I should get the same thing, because if I do 6 plus negative 3, that's still 3. 5 plus 5, that's still 10, so on and so forth. So I get the same exact things. All right, for part B, it is not the same because subtraction is not the same forwards and backwards. So I have, let me erase these so we can actually see them. All right, so I'm doing M minus N, so that would be negative 3 minus 6, which is negative 9. 5 minus 5, which is 0. 2 minus negative 8. So subtracting a negative is adding, so that'd be 2 plus 8, which is 10. And 0 minus 0.2, which would be negative 0.2. All right, so that would be the M minus N. So now we're going to do N minus M. So we're going backwards this time. So we need to do 6 minus negative 3. That would be 6 plus 3, which is 9. 5 minus 5, which is 0. negative 8 minus 2, which is negative 10, and 0.2 minus 0, which is 0.2.